So again, hi and welcome to your CPE 656 Introduction to HDL. Okay, so again, this is week 5, continuation of gate level modeling. Okay, so our focus for today is I will be testing half adder. And sorry for the kung medyo malabo yung ating image. So this is the diagram for the half adder. Okay, so we have A, B, XOR, and then S, and of course our AND, A, B, and C. Okay, so when we say XOR, it's sum is equals to A, XOR B, and for AND, it's carry is equals to A and B. So this is our truth table. So based on our truth table, if A is equals to 0, okay, B is equals to 0, of course your sum is equals to 0, and your carry is equals to 0. So for the input, if A is 1, and if B is 0, your sum is 1 and your carry is 0. Okay, so for your input is 0, okay, and your A is 0, B is 1, your output or the sum is equals to 1 and your carry is equals to 0. Okay, if your A is 1, your B is 1, your sum is equals to 0 and your carry is equals to 1. Okay, so let's proceed with the okay, so let's go to the Notepad++. So let's start with the module. Okay, then let's use half adder. Okay, one that V. Okay, that will be our okay, half adder one. Okay, so we'll use A, B, okay, sum and carry. Okay, based here we have sum, carry, and A and B. Okay. Can you see my Notepad++ class? Okay.
Yes, sir.
So let's proceed. So let's save this as file, save as. Of course, again, you still remember, diba? You have to save it in your C, where did and then iVerilog, and then bin. Okay, so let's continue. So the file name now is halfadder1.v. Okay, of course, what is our input? Okay, so our input here is A and B. This one and this one. A, B. Okay, and then of course our output equals to is sum and of course carry. Okay, and then of course we'll be using gate level modeling. Okay, so the formula for gate leveling for XOR is okay. I just named this one X1. That is the name. This is your XOR. This is your name for your XOR. Okay, this sum A and B. Okay, and then for AND, let's say AND one. This is carry A and B. Okay, of course, and module. So we have now our half adder one.v. Okay, so next we're going to do our test bench. Okay, so file, new. Okay, for our test bench, let's use module half adder underscore tb. Okay, half adder one underscore tb. And of course, let's save this as Oh, I save this as half other 1 underscore TB. Again, our input is A and B. Our output is sum and carry. Okay? Then, of course, our half other. Okay, we'll use half other 1 A, B, sum, and carry. Okay, still remember, initial, we'll be using initial, then begin, then of course our monitor. Then we'll be using okay, time is equals to %D, then %B, %B, okay, then sum is equals to %B, for our carry is equals to okay. Then of course we'll get our dollar time. Okay, still remember. Okay, then let's have the initial value for A and B. So our initial value for A is equals to 0 and B is equals to 0. Okay, and then let's set the time. Okay, so B is equals to 1. So after 1 nanosecond, we'll change the value of B. Okay, from 0, this will now change to 1. Okay, after another 1 nanosecond, we'll change the value of A is equals to 1. So our A now here is A is 0, B is equals to 1, and here A is equals to 1, B is equals to 1. Okay, after 1 nanosecond again, we'll change B again to 0. Okay, then end, and then end module. Okay, so let's try. Save all. Okay, let's go to our CMD. Can you see my CMD? My command prompt. Okay, so again, cd dot dot cd dot. Okay, so I'm on my C, then cd I verilog, and for cd bin. So let's run. Okay, for the formula, the code again is I verilog. Okay, dash O. Okay, let's use again HA for half other. Then half, okay, other one dot V, and then our test bench half other 1 underscore TB dot V. Okay, so we compiled it successfully because there's no error. Then of course we have to run VVP. Then let's get the name. This one, this is our name. So what did you notice? Okay, so here, if your value is 0, okay, and 0, of course, your sum is equal to 0 and your carry is equal to 0. Now we will change, after 1 second, we change 0 to 1. Okay, so this is your 0, A, and 1 is B. Your sum now is 1 and your carry is 0. Okay? And then, of course, on the second, this one, another 1 on the second. So that is 1 and 2. So this is 2. Then our value is A is 1, B is 1. So correct. A is 1, B is 1. Your sum is equal to 0. Your carry is equal to 1. And of course, on the third nanosecond, that's why it's 3, we have 1 and 0. Okay? Our A is still 1, and we change our B to 0. So this is 1, 0. Our sum is 1. Our carry is 0. Okay, so again, let's continue. So this will be our full adder. So we have our A, B, then XOR. Okay, then output is W. Then we also have the another XOR. We have A and V, AND gate, and Y. We also have here AND gate, and of course our OR gate. Okay, then what we need to do is, of course, first type module FA, then sum, carry, A, B, and C. Okay, so I saved it as FA, okay, dot V, short for full adder. Okay, let's continue. Okay, of course, our input is A, B, C. Okay, then of course, our output, okay, is sum and carry. Okay, so we'll use wire. Okay, W, okay, this one, W, okay, and then X, and then Y. Okay, so all output. Okay, X and Y. And then let's start with OR. Okay, this is our OR. This is our XOR. Okay, XOR muna. Let's start with the XOR. Okay, so XOR. Okay, so what do we have in XOR? Diba, we have the output W. Ay, sorry. So we have the output W here. So the output is W. And our input is A and B. Okay, for the XOR. A, okay, and B. Okay, and then next we have another XOR. Diba? We have two XOR. And this is the next. Okay, so our next XOR is sum. Okay, and then of course your W and C. This is our output. This is our input, W and the C. Okay, so W and C. Okay, this is different class. This is C, this is sum, and this is carry. Okay, so next, we're done. So let's go to the AND gate. So AND, so what's our first AND? Okay, so let's start with this one. Okay, so this is our output, X. Okay, and our input is, okay, C and W. C here and W here. Okay, so X is our output, C and W is our input. Okay, and then another AND gate. This one is our, okay, this is the next, this one, AND gate. So we have Y as our output, A and B as our input. Okay, so Y, A, and B. Okay, and of course, we also have, don't forget, we also have the OR gate here. Okay, so the output is carry. Okay, and your input is X and Y, this one. Okay, so or, okay, so carry, then X, okay, and Y. And of course, and module. Okay, then of course, let's create our test bench. Okay, so for the test bench, we'll use module, okay, the test bench, okay, FA, that will be our name. Okay, so let's save this as, okay, right, so tbfa dot v. Yeah, so I save it as tbfa dot v. Okay, then let's start. Reg for input, we have A, B, C. Okay, and then of course our wire, sum and carry. Okay, then our FA is, okay, I renamed FA as FA1. So sum, okay, carry, A, B, and C. Let's start. Initial, then of course begin, and again we'll use the display. Dollar display. Okay, so A, B, C, okay, sum, and carry. Okay, and then of course we'll monitor. What do we want to monitor? Okay, A, we include that one. Then B, of course, then C, okay, and then sum, and of course carry. Okay, so let's give the initial value for A, B, and C. So A is equals to 0, B is equals to 0, okay, and C is equals to 0. Okay, then after 10 nanosecond, okay, I want C1 to change to 1. So our value now is A is equals to 0, B is equals to 0, C is equals to 1. So after 10 nanosecond again, I want to change B to 1, okay, and C to 0. So our value now is A is equals to 0, B is equals to 1, C is equals to 0. Then after 10 nanosecond again, I want to change C to 1 again. Okay, so our value now is A is equals to 0, B is equals to 1, C is equals to 1. Okay, so after 10 nanosecond again, I want to change the value. A is equals to 1, okay, B is equals to 0, and C is equals to 0. Again, after 10, C is equals to 1, okay, we'll change the C to 1. So our value here now is A is equals to 1, B is equals to 0, C is equals to 1. Again, so it's up to you. It depends on your input. B is equals to 1, then change our C again, is equals to 0. Then after 10 nanosecond, C is equals to 1. Okay, then of course, and then end module. So it's up to you what values you want to insert here. Okay, so again, let's try to run. Save first. And then let's run. So we're already on our bin. Okay, so let's try to run iverilog, okay, -o. Okay, let's use FA for full adder, and then FA.v. Then for our test bench, okay, we named it tbfa.v. Okay, and then let's run dbpfa. Okay, so that is our output now. We have the A, B, C, sum, and carry. Okay, if you notice here, if your A is equal to 0, your B is equal to 0, of course, your carry and sum is equal to 0. Okay, this is the initial state. Okay, 0, 0, 0, 0. Okay, and then if your A is equal to 0, B is equal to 0, C is equal to 0, your sum will be 1, and your carry is equal to 0. Okay, of course, if your A is equal to 1, your B is equal to 1, your C is equal to 1, your sum and carry is equal to 1 also.